Hello all, welcome to i-tutor Academy. In today's session, we will start with the Unit 13, Data Warehousing and Data Mining. So, structure of this unit are, there is an introduction, objectives, operational and informational database, the data warehouse schema, and metadata, data warehouse and the web, online analytical process, and data visualization, data mining, summary, and unit and exercises. Introduction. Start with an introduction. And use of IT in all the field and business sectors is well known today, and developments taking place have made information communication very easy. A smartphone is sufficient today to generate and disseminate information across without barriers, and same information is possible today to make available over many channels through email, social media, messaging system, and so on in unfade way. And automation of day-to-day activities, availability of internet is very every nook and corner. Ease of governmental policies is starting business. Use of IT by one and all in business are producing more and more volume of data which are used today for various analytical purposes. Such analyses are also used for proactive strategic decision. Availability of resources like cloud computing, SaaS, and software as a service, PaaS, and platform as a service, etc., have made it possible to dig out data from around the globe. In this unit, we will discuss the concept and use of data warehouses in terms of how they have evolved, matured, and taken the world of business by storm. And objectives of this unit are, after reading this unit, you should be able to identify the type of data in data warehouse, describe the design decision involved in data warehouse design, and explain the importance of building an enterprise data warehouse, depict the architecture of a data warehouse and its various components, and describe various aspects of star and snowflake schemas. Define and explain the concept of metadata in the data warehouse. Enumerate the importance of external data feed from the World Wide Web to the data warehouse. Describe the process of data analysis and online analytical processing, and develop a case for the business value of visualization of data, and apply data mining tools for discovery of hidden relationship and patterns in business data. Operational and informational database. There are several reasons that have compelled information system designers to accept that even the latest technology cannot be optimized to support both operational and informational or analytical processing in a cost effective manner. The reason may be like following, that is, data required is different, the information required is different, and the technology required is different, user community is different, processing characteristics are different, the system loading pattern is different, and furthermore, high level business objectives provide the framework for competitiveness and growth to an enterprise in the long run. To set realistically achievable objectives and monitor the company's performance against them, managers need information on subjects like customers, products, and distributors. It is also beneficial to aggregate measures like quantities of product and sales value across various dimensions like geographical region and time, and compare them with the yardsticks like budgets, forecast, previous years, actual and industry average. And in today's world sounded by IT and its application, it is more comparative as they may be considered as the basic requirement for online businesses. Table here, operational and decision support data, and primitive data or operational data, derived data, DSS data. So, primitive data or operational data is application oriented, detail accurate as of the moment of access, serves the clerical community, can be updated, run repetitively. Derived data or DSS data is subject oriented, summarized, otherwise refined, represents value over time, snapshots, service the managerial community, is not updated like that. Information systems have evolved from the master file or transaction file and the sequential processing of the 1960s to DBMS based random access processing of the 1970s to high performance transaction processing during the 80s to decision support system built around the existing operational, informational, and virtual database. The traditional IT departments with limited resources when faced with the need to provide strategic information using data in operational database find themselves inadequately equipped to respond. Some of the difficulties faced are IT received too many ad hoc requests and resulting in a large overload with limited resource. IT is unable to respond to the numerous requests in a timely fashion, and requests are not only too numerous, they also keep changing all the time. The users need more reports to expand and understand the earlier reports. And the users find that they get into the spiral of asking for more and more supplementary reports, so they sometimes adapt by asking for every possible combination, and which only increases the IT load even further. And the users have to depend on IT to provide the information. They are not able to access the information themselves interactively most of the time. The information environment, ideally suited for strategic decision making, has to be very flexible and conducive for analysis. The solution to the problem lies in the paradigm, the data warehouse. It is an environment that is specifically designed to hold data required to support complex analysis and detection of patterns, trends, and deviations. The characteristics of such an environment can be summarized as follows: provide an integrated and total view of the enterprises, make the enterprise's current and historical information easily available for decision making, makes decision support transactions possible without hindering operational system, and renders the organization's information consistent, present a flexible and interactive source of strategic information. The data warehouse. We have understood the need and importance of data warehouse to facilitate strategic decision making. The concept of a data warehouse given by Bill Inmon, the father of data warehousing, is depicted. So figure 13.1 is here. What is a data warehouse? Data warehouse. A data warehouse is a subject oriented, integrated, time variant, non volatile collection of data in support of management's decision. The defining characteristics of a data warehouse are subject orientation. Data warehouse data of an organization are arranged and optimized to provide answers to question coming from diverse functional area within a company. Therefore, the data warehouse contains data organized and summarized by metadata and keywords by topic such as sales, marketing, finance, distribution, transportation, etc. For each one of these topics, the data warehouse contains specific subject to of interest, product and customers, departments, regions, and promotion, and so on. And time variancy, we have already noted that the DSS data include a time element, and in contrast to the operational data which focuses on current transactions, the warehouse data represent the flow of data through time. And non-volatility, once data enter the data warehouse, they are never removed because the data in the data warehouse represent the company's entire history. The operational data representing the near term history are always added to it. The near term history information is gathered and stored by the data collecting IT tools. One such example by IBM is Omega Mon XZ for their DB2 and RDBMS. And because the data are never deleted and new data are always added, the data warehouse is always growing. And integrations. The data warehouse is a centralized consolidated database that integrates data derives from the entire organization, and the data warehouse consolidate data from multiple and diverse sources with the diverse of formats. And data integration implies a well organized effort to define and standardize all data elements. This integration effort can be time consuming, but once accomplished, it provides a unified view of the overall organizational situation. Operation data and data warehouse data. There is characteristics, operational data base data and data warehouse data. Integrated characteristics are integrated, subject oriented, time variant and non volatile. So, operational database and data warehouse data. In operational database data, similar data can have different representations or meanings. And data are stored with a functional or process orientation. In time variant, data are recorded as current transaction, and data updates are frequent and common. So, this is non volatile nature. And here again, there is depicts the architecture of a data warehouse. So there is data information decision is there. The load manager. Data flows into the data warehouse through the load manager. The data is mostly extracted from the operation databases and other internal sources and supplemented by data imported from external sources. Externally, sources data can greatly enhance the value of information generated from a data warehouse. So example is here. And the type of data from external sources that may be included in data warehouse are financial indicators and statistics of the industry, market share data of competitors and demographic data, weather data, credit worthiness data, and readership or viewer survey data for advertising, media, specially commissioned survey, and so on. External data is usually obtained from commercial database service or government agencies, and the data from such a diverse source will obviously be in different compatible and format and will be distributed through various media, and some of them may be available on a downloadable and format from virtual database on the internet. Other may be distributed on secondary storage, while some may only be available on printed media. The load manager primarily perform what is termed an extract transform load ETL operation: data extraction, data transformation, data loading. So data extraction, this function has to deal with the numerous data sources. Appropriate techniques have to be employed for each data source. Source data may be from different source and mechanics in diverse data format, and part of the source data may be in relational and database system, and some data may be on other legacy network and hierarchical data model, and many data sources may still be in flat files. There may also be the need to include data from spreadsheet and local departmental data sets. Data extraction can become quite a complex operation at times. Various tools are available on the market for data extraction. Use of outside tools may be considered suitable for certain data source. For the other data source, in-house programs may be also needed to be developed to do the data extraction. And after extraction, the data needs to be kept somewhere for further preparation. Sometimes the extraction function is performed in the legacy platform itself if that approach suits the designed framework. More frequently, data warehouse implementation teams extract the source data into a separate physical environment from which moving the data into the data warehouse would be easier. Data transformation: in every system implementation, data conversion is an important function. For example, when implementing an operational system such as a magazine subscription application, the database has to be initially populated with the data from the existing system records, and the conversion may either be from a manual system or from file oriented system to a modern system support with the relational database or object oriented table. As already discussed, data for a data warehouse comes from many disparate sources. If data extraction for a data warehouse poses great challenges, data transformation present even greater challenge, and a number of individual tasks are performed as part of data transformation. First, the data extracted from each source is cleaned. Cleaning may be correction of misspelling or may include resolution of conflict between state code and pin codes in the source data, or may deal with providing default values for missing data element or elimination of duplicate when the same data is brought in from multiple source system. And the data transformation involves many forms of combining piece of data from the different source, and in some cases data from a single source record or related data elements from many source records are combined. In other situation, data transformation may also involve purging source data that is not useful and or separating out source record into new combination. During data transformation, sorting and merging of data takes place on a large scale in the data staging area. And please go through your Ignou study material also parallelly. Please read these sections. And let data loading. What is data loading? And two distinct group of tasks from the data loading function. After completion of the design and construction of the data warehouse, when it goes live for the first time, the initial loading of data is done. The initial load moves large volume of data which may take substantial amount of time, but it is a one time effort. The query manager provides an interface between the data warehouse and its users. It performs tasks like directing the queries to the appropriate table and generating views on an ad hoc basis if required, monitoring the effectiveness of indexes and summary data and query scheduling. Data warehouse design consideration. The key considerations involved in the design of a data warehouse are time span, granularity and dimensionality, aggregation, partitioning, and the time span. The operational data represent current transaction, and such a transaction might define a purchase order, a sales invoice, an inventory in movement, and so on. In short, operational data cover a short time frame. In contrast, data warehouse data tend to cover a longer time frame, and managers are seldom interested in a specific sales invoice to customer X. Rather, they tend to focus on sales generating during the last month, the last year, or the last 5 years. Rather than the concern themselves with a single customer purchase, they might be interested in the buying pattern of such a customer or a group of customers. Granularity, according to Hinmon, and the single most important design aspect of a data warehouse is the decision on granularity. It refers to the level of detail or summarization available in unit of data in the data warehouse. The more detail there is, the lower the level of granularity. The less detail there is, the higher the level of granularity. And operation data represents specific transactions that occur at a given time, such as customer purchase of product X in store A. And this granularity is taken for granted to be of the lowest level in operation systems. And the data warehouse data must be presented at different level of aggregation, from highly summarized to near atomic. And the decision on granularity level profoundly affect both the volume of data that resides in the data warehouse and the type of query that can be answered. A trade-off exists between the volume of data in the data warehouse and the level of detail of queries. Some data warehouse are designed to support dual granularity, and in such an environment some data is held at a relatively low level of granularity while the rest is held in more summarized form. And this enables detail analysis, at the same time allows reduction of data volume. Granularity is here, please refer this figure. And dimensionality. What is dimensionality? This is probably the most distinguishing characteristics of a data warehouse. And from the data analyst's point of view, the data is always related in many different ways. For example, uh, when the when we analyze product sales by customer during a given time, we are likely to ask how many widgets of type X were sold to customer Y during the last 6 months. In fact, the question tended to expand quickly to include many different data dimensions. Figure 13.4 is there, dimensionality of data warehouse data. The data model used for modeling data warehouse is known as the dimensional model. The numerical measurements related to the business are sorted in fact table. The description of the dimension are stored in dimension table, and we will discuss this in more detail in later sections. The number and the type of dimensions and facts that are to be stored in a data warehouse is very important design decision, and affects both the data volume and the type of analyst that can be supported. Aggregations. We have seen how data analysis queries direct at data warehouse involve dimension. Another very common type of query detected at a data warehouse involves sum of values along the different dimensions. An example is here: what is the total sales volume of VCR during the past 4 quarters? Okay, so that is an example. And partitioning, one of the essence of the data warehouse is flexible data storage management and access. And when data resides in large physical units, and among other things, it cannot be indexed easily, and sequential scanned if needed, and structured easily, and backed up conveniently, and recovered easily, and monitored easily, and so on. In short, having a big mass of data defeats much of the purpose of the data warehouse, and the purpose of partitioning is to break the data into smaller physical unit of storage. The criteria used for dividing the data can be data line of business, product category, geography, location, organizational, administrative unit, or any combination of this. And activity A is here based on this subsection. Please try to do it, and in between any doubts you can contact us anytime. Thank you. For more MBA videos, you just do like, share, and subscribe.
i-tutor Academy presents Ignou MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.